All right.
Hello, everyone. We are excited to present our final project, Intent Detection with DistilBERT, a scalable deep learning approach for natural language understanding. This project was developed by our team Mohammad Omar, Arpita Kachra, and Nikita Bhosle as part of the AI System Technologies course. Our goal was to explore how deep learning can be applied to natural language understanding and how we could build a production ready real time system around it. We have leveraged modern AI tools like Hugging Face Transformers, Fast API, and Vercel to create an application that is not only accurate and efficient but also production ready. Here is a brief roadmap of our presentation today. We will begin by discussing what intent detection is and why it matters in the current AI landscape. We will then explore our choice of technology, why we opted for DistilBERT over other models. Next, we will walk you through the system architecture we developed, including the front end, back end, and deployment strategy. We will also share a live demo snapshot to show how our system works in practice. After that, we will dive into the core features, benefits, and real world deployment challenges we encounter. We have also included an ethical analysis to highlight responsible AI practices. And finally, we will share our thoughts on future enhancements before concluding. Let's begin with why intent detection matters. Intent detection is the foundation of many AI powered services. Whether you are using a chatbot to reset a password, asking a virtual assistant for weather updates, or interacting with a voice based travel planner, intent detection is what helps the system understand your query. In technical terms, intent detection involves classifying user input into a predefined set of categories. This task is fundamental to enabling natural language understanding. As more companies turn to AI for automation, robust intent classification becomes essential for delivering personalized and efficient services. Our goal with this project was to build a solution capable of handling a wide range of user intents, specifically 150 categories across diverse domains such as banking, travel, and utilities. We see applications in IT support automation where bots handle tickets based on user intent, e-commerce for handling reference, shipping updates, and product inquiries, travel planning and banking where precision and personalization are critical. The better an AI understands user intent, the more human like and effective the interaction becomes. We chose DistilBERT for several important reasons. DistilBERT is distilled lighter version of the original BERT model developed by Hugging Face. It retains 97% of BERT's accuracy but uses 40% fewer parameters, making it more efficient and faster to run. This is crucial for real-time applications where latency and response time matter. In our testing, DistilBERT provided significantly faster inference times without sacrificing performance. It's also ideal for environments with limited computational resources such as mobile devices or cloud-based microservices. DistilBERT gave us the flexibility to fine-tune a powerful NLP model that could run in real time without needing a GPU backup.
Okay. So let's talk about the data set. To train our model, we used Clinic 150 dataset, which is one of the most comprehensive benchmarks for intent classification. It contains over 23,000 utterances categorized into 150 intent classes. The dataset spans 10 domains, including banking, travel, utilities, weather, and more. This diversity ensures that the model learns to generalize across different kinds of user queries. For example, a sentence like, "How can I reset my password?" is labeled under intent of account password reset. Uh, because of the large number of distinct classes and real world phrasing used in the dataset, it provided an excellent foundation for building a highly generalizable model. In terms of the system architecture, our system follows a modular and scalable architecture designed with deployment and maintainability in mind. The front end is built using React with Vite, which offers a fast development experience and efficient production builds. We hosted this front end on Vercel, which provides seamless CI/CD and global deployment pipelines. The backend is powered by Fast API, a lightweight and asynchronous Python web framework that is ideal for serving machine learning models. We deploy the backend using Railway, which supports containerized developments and automatic scaling. The model itself is fine-tuned using Hugging Face transformers and hosted on Hugging Face Hub, which allows for secure and fast model access without burdening our backend storage. All communication between front-end and backend occurs via JSON APIs, with cores properly configured for cross-origin interaction. Here you can see a working example of our deployed application. A user enters the query, and the query could be anything along the lines of what is the time right now. This input is then sent from the front end to the backend via post request. The backend then tokenizes and models it to predict the intent. And in this case, the intent would be time with a confidence score of 0.9862. This result is returned to the front end and displayed to the user. The entire process from user input to model prediction takes less than a second. You can interact with the system yourself using the links provided. The front end UI is hosted on Vercel, and the backend API is fully documented on Railway. Now, talking about some of the key features, our application includes several notable features. First, it supports classification across 150 unique intent categories, offering a broad coverage of user categories. Second, the system performs real-time inference by calling the Hugging Face hosted model from our backend. Third, we designed a responsive and clean user interface using React, making it intuitive for both developers and end users. Fourth, our model is version controlled and serialized, allowing easy updates and rollbacks. All of this is hosted on our GitHub repository, which is publicly available. Lastly, the system outputs a JSON response that includes both the predicted intent and the confidence score, which is useful for transparency, monitoring, and integration with other services.
All right, now let's talk about the benefits of a system. First, it's scalable and fast. Using DistilBERT with Hugging Face allowed us to deliver quick responses without compromising our accuracy. The system is capable of handling real-time queries, making it suitable for production environments. Second, the deployment is really simple. Thanks to Vercel and Railway, setting up the front end and back end with CI/CD pipelines was smooth and scalable. Third, the model is highly accurate, letting us achieve 88.5% accuracy with an F1 score of 88.1%. This makes it reliable for real-world use cases. And finally, it's open source and reproducible, meaning anyone can clone the code, test it, or build on top of it, making it a suitable foundation for future NLP applications. Moving on to the next slide. So here comes the challenges and solutions. Like any real world AI project, we faced a few challenges during our deployment. One issue was the GitHub file size limit. Our model was too large to upload, so we solved that by hosting the model on Hugging Face Hub. And we also ran into course errors when connecting the front end and back end. So to fix that, we properly configured course settings in our Fast API app, and lastly, we dealt with PyTorch compatibility and serialization issues, especially when moving between the environments. So we tackled that by pinning dependency versions and validating everything both locally and in the cloud. Next slide, please. Okay. And ethics plays a key role in how we design the system. We only use public and anonymized data, so no personal user information was ever involved in this. The system doesn't collect or store any inputs. It's built with privacy by design. So we also reviewed the data set to check for any bias and diversity, making sure a model could generalize across various user groups. And finally, the whole system is transparent and open source, allowing for community feedback, audits, and future improvement. Next slide, please. All right. So talking about the future scope and expansion, there's a lot of room for to grow from here. Area is multilingual classification. We want the system to detect intents in multiple languages, not just English. So we also see value in voice integration, allowing users to speak their queries, making it more accessible and natural. Another exciting direction is adding explainability tools like SHAP or Line. This will, help developers and users understand why the model made a certain prediction. And finally, we want to integrate this into an enterprise chatbot platform to, help companies reduce support costs and improve customer experience. Next slide, please. Right. So to wrap this up, this project shows how deep learning, especially with efficient models like DistilBERT, can power robust real-time language understanding. We were able to train, fine-tune, and deploy a model that supports 150 different intent categories with strong performance. We faced and overcome real deployment challenges, prioritize the privacy, and build something that's just not theoretical, but ready to use and improve further. So it's a practical, ethical, and scalable foundation for future AI systems. So thank you so much for your time, and we hope this gives one a clear understanding of the project. Thank you.